dividing surds is probably one of the most complicated part of doing arithmetic with surds. So in this video, I'm going to show you a few different examples of things that you might see when division and surds is involved. So we'll start off with probably the simplest part, which is just where we simplify some fractions that involve surds. Then we'll look at what's called rationalizing denominators. So that's all about getting rid of surds from the bottom of a fraction, from the denominator of a fraction. It's just a bit of a convention thing that we don't like to have surds on the bottom. And then finally, a bit more complicated version of rationalizing the denominator, which will involve bringing back the difference of two squares formula that you might remember from earlier algebra. So the first example that I've got here is square root of 33 divided by the square root of 11. So obviously that's a division, it's a fraction division of two surds, the square root of 33 and the square root of 11. And there's actually a few ways that we can deal with this, but the way I'm going to do it is to change it from a surd divided by a surd to a single surd of a fraction. So that's actually something we can do, which is to write that as the square root of 33 over 11. Now we can do that in general. We could say that the square root of x divided by the square root of y is the square root of x divided by y. Assuming, of course, that y is not 0 or something else that would break the rules there. Okay, so we've got our square root of a fraction, and we can then simplify that a bit because 33 divided by 11 is just equal to 3 by simplifying the fraction. So we end up with our simplified result of the square root of 3. So that's simplifying the fraction basically to get rid of a surd from the denominator, but also to divide two surds. The next example is pretty similar, except that the quantities in the surds are a bit more complicated than the first one. Got some pronumerals, some letters in there, but I'll track this one the same way. So I'm going to turn it into a single surd of a fraction, 3x squared y divided by xy. And then I can do a little bit of cancelling. The y's will cancel, and an x on the bottom with one of the x's up the top. And then all we've got left then is a 1 on the bottom and 3x on the top. So we end up with the square root of 3x. So there we go. Surds divided, and we want to get rid of there being any surds on the denominator as well. And we've done that, so that's good. Okay, so the next one along. Again, dividing two surds, the square root of 15 and the square root of 7. And at first glance, it looks like you'd probably do it the same way as this one. But I can see already that even if I put it as the square root of 15 over 7, I can't really cancel anything out in there. So it hasn't really made it any simpler. So this one I'm going to show you how to what we call rationalizing the denominator. So there's a convention in mathematics that we like to get rid of any surds on the denominators of fractions, and that's called rationalizing the denominator. Because a surd is, generally speaking, an irrational number, so to get rid of it from the denominator is to rationalize the denominator, turn it into a rational. Okay, and the way that we do this all comes down to the idea that when you multiply the square root of something by itself, you end up with just the number from under the square root. So the square root of x times the square root of x is equal to x. Okay, and x is no longer going to be that surd form. So what we're going to do here is say that the square root of 15 on the square root of 7, I'm going to leave that, and we're going to multiply it by a quantity. I'm going to multiply it by the square root of 7 divided by the square root of 7. Now, you might be thinking one of two things. One is, why did you do that? Well, what I'm going to show you is that multiplying those two quantities on the bottom is going to get rid of that surd, that square root. We'll be left with a 7. So we'll have got rid of the surd on the denominator, rationalized the denominator. But the other part of it is, well, if I multiply by something, haven't I changed what the fraction is? But what I'm doing is multiplying by this quantity here, which is just a weird looking 1. Okay, think about that for a sec. The square root of 7 divided by the square root of 7 is equal to 1. Okay, so we're not really changing what the value is here. We're just going to change what it looks like. So let's follow that through. When we multiply two fractions, we multiply the tops and we multiply the bottoms. So we're going to have the square root of 15 times the square root of 7 on the top, and the square root of 7 times the square root of 7 again. That's just going to give us a 7 on the bottom. Okay. And then finally, if you remember back to when we multiply surds, we can just write that as the square root of 15 times 7, which is the square root of 105, I believe. Yes. Okay, and that's all over 7. Now I guess to finish that off, we should check that the square root of 105 doesn't have any perfect squares in it. 4 doesn't divide into that. Neither does 9. Neither does 16. Not 25. And not 36. Not 49. And certainly not 64. We don't need to go any further. So we don't need to worry about that. That square root of 105 is our simplest form. Okay. Now the last one is probably the hardest. There's a bit more involved in it. We've got to divide 3 by 7 minus the square root of 5. Okay, and the idea that we're going to do here is similar to this example where we multiplied by 1, but in a weird looking form. But it's not quite as simple as just multiplying by the surd that's on the bottom. If we just multiplied this whole fraction by the square root of 5, sure, it would get rid of that one, but we'd still have 7 root 5 when we expanded out the bracket. So we can't do that. What we're going to do is remember that when we multiply a plus b and a minus b, we always get a squared minus b squared. Okay, the difference of two squares formula. So we can use that with a quantity like this, something minus something. If we multiply it by that same something plus the square root of 5, or whatever the surd happens to be, the difference of two squares is going to help us to get rid of the surds. So what I'm going to do is leave our 3 over 7 minus root 5. I'm going to pop those in brackets. You'll see why in a moment. And I'm going to multiply by 7 plus the square root of 5 over 7 plus the square root of 5. Okay, so hopefully you can see this whole quantity is equal to 1. So we're not changing the value of the fraction, we're just going to change what it looks like. And when we multiply across the bottom, we'll be able to use the difference of two squares, and we'll see that it gets rid of the square root of 5. Okay, so let's try it out. I'm going to multiply across the top. I'm just going to leave this one unexpanded for now. 3 times 7 plus the square root of 5. And on the bottom, we're going to have 7 times 7 is 49, minus root 5 times 7, or minus 7 root 5, and plus 7 root 5. And finally, minus root 5 times root 5, minus root 5 all squared. Okay, so let's see how that clears up. Leave the top. Down the bottom, we are going to lose that with that one, minus 7 root 5 plus 7 root 5, and take away root 5 all squared, and that's going to be equal to 5. So we've got 49 minus 5, and clean that up. 3 outside of 7 plus root 5, all divided by 44, which is 49 minus 5. Okay, so you can see we've now got no surds left on the denominator. And that all comes down to the difference of two squares and having chosen the right thing to multiply by up the top here. Okay, so that's kind of the kind of things you'll see if you are dividing surds, all the way from simply simplifying fractions to seeing some pronumerals popping in, and then to rationalising the denominator, either a simple surd in the denominator or an expression where we're adding or subtracting a surd. And that even works if you've got two surds down here as well. It still works with the difference of two squares. Okay, so there we go, dividing surds.